Thank you for joining today's seminar, and thanks to Michael and Shubit for inviting me. I am Sazadur Rahman, a new faculty here at the College of Engineering and Computer Science. Today, I'm going to talk about my research on end-to-end security assurance of microelectronics supply chain and how it brings multimodal collaboration opportunities at CECS. So I am an assistant professor at the Department of Electrical and Computer Engineering. I also have a secondary appointment at Cybersecurity and Privacy Cluster. I finished my bachelor back in 2014 from Bangladesh. After that, I joined Silicon, which is actually a part of Synopsys now, as a design engineer. I worked there for a couple of years. Then I came to UF to finish my master's and Ph.D., which I received on December last year. My PhD was mostly sponsored by DARPA, thanks to their support throughout this time. And after that, I joined Intel as a security architect for a couple of months before I started my position here at UCF. I do a lot of traveling and gardening during my free time. I love to cook as well. So that is something that always recharges me to do wonderful research. I hope you can find me in the middle of the park here. So now let's talk about the business. So I will first start with the current semiconductor business model. We all know how the chips are driving the economy these days. To design a chip, you need to start from licensing the intellectual properties, which are the functional building blocks, and then codifying that design, performing the architectural improvements, implementation, fabrication, packaging, testing, and then you finally get the chip that you have been looking for. During these steps, there are many parties involved who are actually distributed globally, like some companies might be working from US, some companies from Europe, some from Asia. So there is definitely a lack of trust and security concerns, which brings the threats like piracy, reverse engineering, and malicious circuits and tampering. So you guys might be wondering if this is actually real. To give you a flashback, like back in 2018, we discovered there was a malicious circuit in one of the server chip. This server chip was actually used by CIA, Amazon AWS, and many other government agencies. And you can understand how catastrophic it was to find such a security vulnerability in some of the most confidential operations there. So as I already mentioned, like there is many different types of security threats like piracy and reverse engineering, and most of the cases the victims are like the IP vendors and the design houses who are developing these chips. So I developed several hardware obfuscation, authentication, and hardware assurance solutions to mitigate this kind of security vulnerabilities in the semiconductor supply chain. So this is more like my research landscape, how the outcomes of my research, like different publications, patents, and one of the book I wrote are actually mapped to this kind of different solutions that I developed to bring trust and security in the semiconductor supply chain. The thing is the overall manufacturing and the design process of semiconductor nowadays is so complex, and there are so many loopholes that the attacker has many scope of performing the malicious acts in the supply chain. And that has been keeping me busy all the time and kept me sleepless in the night to develop some of the state-of-the-art solutions that I did during my PhD. I'm not going to bore you to discuss all of these different techniques, but I will pick one of these, which is the hardware obfuscation that I worked mostly during my PhD. So hardware obfuscation actually aims to protect intellectual properties and your chip by hiding the design functionality from untrusted parties within the supply chain. For this work, I collaborated with lots of government agencies, industry, to come up with several solutions and provide a comprehensive mechanism to protect the IC. So to understand what IP piracy means, let's say you have one SoC which for which you are using, let's say, the CNN accelerator as a third-party IP. So in this case, you are definitely paying a royalty credit for this IP, which is actually giving the revenue to the IP designer. What if there is some other company which actually steals this IP from your SoC and use in their SoC without paying the royalty credit? So that is what we mean by IP piracy. If we bring it down to how these intellectual properties are actually designed, So there are 4 different components, which are your control circuitry, you can call it FSM, like finite state machine, your data path, your clock network, and the design, which is used for testing your circuit. So I developed, which is called a difference in depth solution, like how we can protect each of these individual pieces of your IP to ultimately provide the comprehensive solution. So I developed a reconfigurable computing-based data path protection technique, and then I developed a FSM obfuscation mechanism to protect your control circuitry. Then I also developed a clock-gate locking mechanism to make sure that your clock network is actually doing the right thing and not leaking anything to the adversaries. And then at the same time, I developed a testability mechanism that actually makes sure that once you ship your chip to the offshore foundries and they help you to do the testing, you can still make sure that your design is protected. So I did not just stop after developing the countermeasures. I also wanted to make sure that my countermeasures are working the way it is supposed to. So I challenged my countermeasures by developing a security metric, which I did using several properties that I generated by transforming the circuits into a graph and then harness the features from them. After that, I used a machine learning model to make sure that we can tell you how much protected your developed countermeasure is against some of the cutting edge attacks and vulnerabilities in the community. So we have been actually very much successful in developing these countermeasures, and we were fortunately granted actually 1 patent and several publications in this domain. I also hosted a hardware obfuscation competition where 9 different institutions participated, and no one was able to break my designs. And I also wrote a book on this topic, which was published a couple of months earlier. So that is mostly my previous work, and I actually gave you a brief discussion of what I did in one part of the big domain. So that might be asking you like, what's next? So for now, I'm trying to expand my research portfolio by collaborating with lots of other faculties in the department, which brings one of the very first project that I'm currently working on at UCF. So the thing is, data privacy is one of the biggest concerns these days, and you cannot tackle it with just protecting by your software. And it becomes even more critical when these data are used for, let's say, your deep learning networks or neural network application when dealing with confidential data like healthcare data, government agencies data, and then financial institutions. So this is the place where fully homomorphic encryption comes in. So in this case, rather than using your plain text data to perform some of these neural networks and machine learning applications, you protect the plain text data with encryption and you work only on the encrypted data. So that is something that is a futuristic approach and very emerging these days. And the problem with this fully homomorphic encryption is that it is extremely computationally hungry and it takes time. And however, there are ways, and like researchers are spending their days and nights, how they can make it faster and practically implementable for everyone, right? So I'm currently collaborating with some other faculties in the department, like Dr. Du, Xin, and thanks to Reza for doing the awesome networking, to bring AMD and Synopsys on board to collaborate with us in this project. We are trying to develop hardware accelerators for FHE from architecture and bring them to silicon. There are some other projects that I'm also involved with. Like, I know you guys are aware of the CHIPS Act, and when the CHIPS Act gets implemented, it brings cutting-edge fabrication facility and ecosystem inside the US. The thing is, the most of the hardware security work, like the obfuscation work that we did during my PhD, we used to consider that the foundry and testing companies, they are offshore and they are the untrusted guys. The thing is, when the CHIPS Act gets implemented, you can no longer consider them only as the untrusted guys. Even anyone within the supply chain can be untrusted. So that is what we call the insider threat. Like, anyone within the supply chain can be untrusted. The thing is, some of the work I did during my PhD, like reconfigurable computing and then using the lot-based configuration methods to protect your intellectual properties, those have the potential to protect against insider threats. So I'm open to collaborate with computer architects, circuit and device experts, and algorithm experts in this domain to make sure that we can be secured against even the insiders. And I believe you guys are also aware of like how the Moore's law is getting saturated and how the chiplets are actually emerging these days. Because with chiplets, you can bring more computational power in your silicon. For example, the latest AMD and Intel processors that were released like a month ago, all of them were based on chiplets. And if you check their stock, you'll see like how after they like marketed their chiplet-based design, how their stock has increased. So chiplet is actually the future whenever we talk about semiconductor. The thing is, whenever you go to the chiplet level, there is again those trust and security concerns. I believe some of the IP protection methods that I developed, they have the potential to secure your chiplets as well. For this, I'm open to collaborate with device experts, architects throughout the school, and then digital design and VLSI experts. This is the other piece of my work that I'm currently working on. Like to design these chips, you need tools. And these tools are called electronic design automation tools that deliver you the cutting edge chip. The thing is, nowadays, people are trying to replace human by equipping this tool with machine learning. However, with greater performance, it brings greater responsibility as well, because these machine learnings that are driving EDA tools now, they are making new concerns on reliability and security. So that is why I'm also expanding my research work, how we can make sure that we can at the same time use the machine learning tools without creating additional vulnerability in the domain. For this one, I'm open to collaborate with machine learning and VLSI experts. Feel free to reach out to me if you want to collaborate with any of these topics. I'll be happy to move forward. My long-term vision is to develop secure semiconductor workforce from here. So the thing is, CHIPS Act will require more than 50,000 engineers in the next couple of years. And if we want to make sure that we can take the lead on semiconductor design at US, we need to make sure that all the steps that goes through to design a chip, we are taking the lead in each of these steps. And that is why I am also trying to collaborate with the faculties in the department. I'm a part of the curriculum review in the computer engineering domain to make sure that we can give the right tools and expertise to the students. We can make sure that they have all the expertise they need to make sure that CHIPS Act and the semiconductor leadership is regained by US. And my research is always there to back me up and find the caveats in this process and do the needful. And I'm very thankful to be a part of this institution. And so far, my ramp up at UCF has been going wonderful. I am also thankful to my graduating institution for actually preparing me and building me so far what I have achieved. And at the same time, I'm thankful to the sponsors that I have been working with. So that has been all about me. If any of you find this interesting or want to know more about my research, feel free to reach out to me. I'm always happy to collaborate. And if you have any question, don't forget to paste it in the text or reach out to me.